We'll be focusing mainly on the fundamental counting principle, which is from chapter 11 section 1 during this lecture, but we'll also be talking a little bit about factorials at the very end of the lecture, which leads right into the next lecture on permutations and combinations. So this should be fairly short compared to some of the other lectures. They're all underneath 15 minutes, and this one should be about 10. I'm just kind of guessing. Fundamental counting principle, sometimes called the multiplication counting principle, can be used in situations when you have to figure out the total number of choices you may have, or I think when you see some examples it'll make sense to you. Look at the first explanation there. If you can choose one item from a group of m items and a second item from a group of n items, then the total number of two-item choices is m times n. This concept can be extended for multiple groups of items. Now that might not make any sense at all, but as soon as you see an example of what they're talking about, I think it'll make sense to you. A pizza can be ordered with 2 choices of size. You can either order medium or large, 3 choices of crust, thick, thin, or regular, and 5 choices of toppings. How many different one-topping pizzas can be ordered? Well, some examples of what could be ordered would be a medium thin crust pepperoni, or maybe a large thick crust bacon, etc. So we want to know the total number of possibilities of one topping pizzas you could order. So let me grab a pen here. There are 2 choices of sizes, so that's, let's go here, 2 times, there are 3 types of crust, and there are 5 choices of toppings. So the fundamental counting principle tells you we multiply those, so 2 times 3 is 6 times 5 is 30. We have 30 choices, or 30 possibilities of one topping pizzas we could order off that limited menu, and that's an example of using the fundamental counting principle. Here's another one, and I believe you have a problem just like this on MyMathLab. You're taking a multiple choice test that has 6 questions. Each of the questions has 4 answer choices, either A, B, C, or D, with 1 correct answer per question. If you were to guess on each of the questions, how many ways could you answer the questions? Well, an example might be you might choose A for each one. A. That'd be one choice. You might decide to go with all A's with a B on the last one. There's so many possibilities. To find out how many, well, you just use the fundamental counting principle. You might, for the first problem you'd have 4 choices, second problem you have 4, and we just keep doing that all the way through. On the 6th problem you have 4 choices. So the number of different ways you could answer the questions is whatever 4 times 4 times 4 times 4 times 4 times 4 is, which could be written as 4 to the 6th power. Let's pull up a calculator here. 4 to the 6th power. Oh, by the way, if you ever get that, go to View and go to Scientific. Now you have more choices. Let's go 4 to the power of 6. 4 to the 6th power is 4096. So there's 4096 ways of answering those 6 questions. Once again, that's using the fundamental counting principle. How about this situation? You need to get into your friend's locker, but you don't remember a combination. How many possible combinations are there? Keep in mind the second number cannot be the same as the first on these locks. Well, for those of you that have used locks like this before, let's take a look at this lock. It goes from 0 all the way up to 39, so that's a total of 40 numbers. So for your first number, you'd have 40 choices. For your second number, since the second number can't be the same as the first, you'd have 39 choices. And then the third number could be any number, once again, so that'd be 40. So to figure out how many different combinations there are on a lock that looks like this, you would simply take 40 times 39 times 40. So let's go 40 times 39 times 40, and we get 62,400. So maybe you better call your friend and ask her what the combination is, because it might take you 62,400 times to get the right one, unless, who knows, maybe you'd get it on your first try and get really lucky. Next one, personalized license plates. What if you had your own plate This one says I accelerate. This person must drive fast. But let's say you had your own license plate and you want to make it, and here's what you're allowed: 5 letters followed by a number. How many total possibilities of license plates are there? Well, if you have 5 letters followed by a number, you're going to have 1, 2, 3, 4, 5 numbers or letters followed by a number. You have 26 choices in letters here, 26 choices for the next 4 spots also, right? Now, a common mistake by students is they'll write 9 in here, but it's actually 10 because you have 1 through 9 plus 0, which is a total of 10 digits you could use there. And because of the fundamental counting principle, we're going to multiply all these. Now, I'm not even sure what's going to happen when I put this into the calculator. It might give me the answer in scientific notation. I'm going to cheat and go 26 to the power of 5, because that's 26 times itself 5 times. And then I'm going to take that answer times 10. Okay, it's not big enough where they use scientific notation. So what do we have here? 118,813,760. I'm probably not going to be able to write as I keep that up there. Yep, I lost it. So, you know what? I can't remember what it was. So I'm going to do this, and I'm going to say it approximately equals that. Sorry, but you get the idea. Now, how about same situation, but look what's underlined. This time none of the letters can be used more than once. So we're still going to use the fundamental counting principle, but since the letters can't be used more than once, we've got to think a little bit harder here. We still have 26 choices for this first letter, but since the next letter can't be whatever the first letter is, now we only have 25 choices. And the third letter can't be what either of the first 2 were. So 24, 23, 22, and then we have 10 numbers we can choose there. So I hope that makes sense to you why we're doing it like that. And then I won't grab the calculator, but you would just multiply that out on your calculator to find out how many choices of personalized license plates you could make in that situation. So these are all examples of the fundamental counting principle. I hope it makes a little more sense to you now that you've seen some examples. You'll have quite a few problems on my math lab on those type of problems. Now, this kind of leads up, it's related to what we just learned, and it also leads up to the next section. So when you see an exclamation mark after a number in math, it's not an exclamation mark, it's called factorial. So when you see 4 factorial means 4 times 3 times 2 times 1, and 4 factorial equals 24. Now, let me give you an example when you would use 4 factorial. What if we chose 4 people? Let's say there's children in the classroom and we told 4 of them to go line up at a drinking fountain. Well, and we said, how many ways could those 4 children line up at the drinking fountain? You'd have 4 choices for your first person in line, right? But once that person's been chosen, now there's only 3 choices for the second place, 2 for the third, and then you're left with whoever's left over to go last. So that's an example of using the fundamental counting principle and then using factorials to quicken up the process to find your answer. Because I'll show you where this is at on your calculator here in a second, but let's find out what 6 factorial is. It's 6 times 5 times 4 times 3 times 2 times 1. So that's 30 times 4 is 120 times 3 is 360 times 2, I think it's 720. Excuse me. What we're going to do is use a calculator and see if it's actually 720. So let's clear this off and put in a 6 and then the factorial sign on this calculator. And about all scientific calculators have a factorial sign. There's 6 factorial right there, 720, so we did do that right. Now we're also supposed to find out the value of 1 factorial, and that answer is probably what you think it would be. 1 factorial is 1, and this one might surprise you. 0 factorial is not 0. 0 factorial is also 1, and that'll help you on the next section to know that 1 factorial is 1 and 0 factorial is 1. So let's answer these three questions here. 6 factorial was 720, just like we figured out by hand. 1 factorial is 1 and 0 factorial is 1. Now I think the only other thing I wanted to show you in this lesson was where do you find that on a graphing calculator. For those of you that have graphing calculators, you click on the math button and then cursor over to probability and then go down to factorial. So let me bring up my graphing calculator. Okay, let's say we want to know what 8 factorial is. I'd click on 8, then I click on the math button and I cursor over to probability, and under probability the fourth option is factorial, so I just hit 4. I could either cursor down to 4 or just click on 4, and there we go, 8 factorial, and I hit enter. 40,320. Okay, let's go back to the PowerPoint. I think we have one more slide. Find the value of 6 factorial divided by 4 factorial without a calculator. This is definitely leading into the next section on combinations and permutations, and there's a shortcut on how to do these. So if you take a look at this shortcut, that's 6 factorial, and we're supposed to divide it by 4 factorial. I bet you see what happens here. All of these cancel out. So our answer is just 30. You don't have to actually figure out what 6 factorial is and what 4 factorial is and divide them. You can use the canceling out process. Okay, find the value of 8 factorial divided by 3 factorial, 2 factorial. If I remember right, I had that up on my graphing calculator earlier. Let me see. I'm going to hit second enter and hit second enter until there it is. So you could, the one thing you'd have to remember is to put that 3 factorial, 2 factorial into parentheses like I have it there, so that the calculator knows you want both of those quantities down in the denominator, and when I hit enter we get 3,360. So like I said, the last couple slides on factorials are, you can help them, that can help you with your fundamental counting principle, but it also leads into what we're learning next. So thanks for watching this lecture. The next one's on combinations and permutations. Bye.